Okay, greetings guys. We're going to talk about solving exponential equations. And on the whiteboard here, I have two very easy ones. Of course, they're not always going to be easy, but the concept is the same, no matter how easy or difficult the problem. So in this first one, if I wanted to, I could guess and check, and say, you know what, if x was equal to 3, then I would have 2 cubed equals 8. I would have the solution to that equation. Same thing over here. If I guess and check, hey, I bet if x was equal to 2, I would have the answer to that equation. But here's the underlying principle. In both of these equations, I could rewrite them so that they both have the exact same base value. So this is called a bases match style equation. 8 is the same thing as 2 to the third power. So mathematically, the rule is if the two base values are the same, that implies that the powers must also be equal. So over here on the other one, if I had 3 to the x, I could say, hey, 9, you are the same thing as 3 squared. Since the base values match, I can set the powers equal, so that is x equal 2. Now, you might say to yourself, well, I don't really need to work that hard on that one. It's pretty easy. Well, here's the deal. What if they try to spice this thing up a little bit and they just do something like that now? It's not as easy to guess and check if they try to make this more difficult. Still, it's not the most difficult question I'd ever see. But I can rewrite it so that the bases match. Then I could set the powers equal to each other, and this becomes the piece of the puzzle that I would have to solve. And I would say, okay, 2x plus 5 equals 3. I'm going to move the 5. And we're back in Algebra 1 now. And what's x got to be? X has got to be -1. So when it comes to solving exponential equations, these are what I call bases match style. So let's just play around. You're going to see some practice problems, and they are going to be mixed together. They're going to be mixed together. I won't say this one has matching bases, this one does not, but you can figure it out. So here we go. 2 to the x plus 3 equals 16. Well, play around with it on your calculator. If you are not familiar with this, it is 2 to the 4th power. 2 times 2 times 2 times 2, 4 times, you get 16. So once I do that, I could say, hey, let's make these powers equal. And this one, I don't really even have to think too hard. I move the 3 to the other side. And my answer is x equals 1. So, how do they make these bases match style problems more difficult? Well, they try to throw more junk in the problem. So, for example, let me show you something like this. Now they're trying to make it much more difficult for you to guess the answer. But it's an equation, and one thing we know about equations is you try your best to isolate the part that has the variable. So, treat it just like any other equation. Let's peel away some pieces here to make this thing easier to see. And over here I'd have 32. I'd divide both sides by 2. And then I get 4 to the x minus 7 power equals 16. And this time, instead of saying, well, 16 is 2 to the 4th, yeah, but it's also the same thing as 4 squared. Remember, the object of the game is, can I get the two bases to match? Because if I can, then I can set the powers equal to each other. And what's the answer for this one? X would have to be 9. And there you go. Now, the thing is, they're going to try and step up the game. They're going to try and make things a little bit more difficult for you. So let's take a look at this one. And I'm not trying to be tricky. I'm using the same type of numbers every time. But here we go. We go, well, you can't make 16 into a base of 8. No, you can't, but you could make both of these a base of 2. See, when you're trying to solve an exponential equation, the first thing you want to ask yourself is, could I rewrite that base to match this base over here? And I could write both of these numbers with a base of 2. But what does that mean? I already had a power there. Well, what do we know about powers? Powers of powers are multiplied. So what I'm doing here is I'm just rewriting the base value. Then I end up with a good old-fashioned Algebra 1 style equation again. So no matter how tricky they try to make this look, I can still get this to look like something I did in Algebra 1. And I don't know, it doesn't matter to me. I'm going to move these over here, minus 3x, and then that would give me negative 9 equals x plus 4. So I'm going to move that over to the other side. And here we go. X equals, I'm running out of room there, so I'm just going to write it on the side. X equals negative 13. God, that's a horrible looking 3. Negative 13. So, the only way they can try and make this more difficult is to try and spice it up and put some more stuff in your way. And I'm not trying to be super crazy tricky. I am using numbers that I believe you could figure out, hey, which base do you think I could write both of these? Well, this guy's already a 5. This guy could be written as 5 squared. So I only had to rewrite this side of the problem this time. But once again, back in the Algebra 1 mode, because I know I can set that equal to that, and I will end up with 3x minus 4 equals, well, what the heck, let's distribute. So that's going to be 6x plus 2. And then we finish this guy off. Negative 3x minus 4 equals 2. I'm going to move it over. You might have already beat me to the end here, because I'm writing out every step, which is negative 3x equals 6. So x must be equal to negative 2. Alrighty. Now, of course, it's an equation, so if you wanted to, you could always check to see if your answer is valid. You could plug it back in and verify that one side does indeed equal the other side. Or you should look at my answer key when you see the practice problems and check your answers. Make sure that you are getting them right. Okie doke. So, those are what I call bases match style problems. Now, bases match style problems are not the hard ones. It's when the bases don't match. See, in mathematics, if I had something like 2 to the x equals 10, well, now I know there's no power. Well, what if I plug in 3? I'd get 2 to the third, that's 8. That's not quite 10. If I plugged in 4, I'd get 2 to the 4th, that's 16, which is bigger than 10. So the answer I'm looking for is some number between 3 and 4, but I don't want to guess and guess and guess. I could continue to guess for a long time and not get this right. So here is the reason why logarithms were invented. If I do the same thing to both sides of an equation, I am not changing it. So here's what I'm going to do, and I'm going to just walk you through this a couple different ways. I'm going to take the log of both sides. If I take the log of both sides, what that allows me to do is use the power rule. See, if I'm taking the log of something to a power, then I can rewrite it with the power down in front. We talked about that. That's one of the laws of logarithms. Then on the other side, I have log of 10. Now, I don't want x times log of 2. I don't, but I can divide by that. And I could say, well, the log of 10 divided by the log of 2, that should be my answer, because over here, if you divide something by itself, you get to cancel it. It's 1. Now, log 10 divided by log 2, when I try to punch this in on my calculator, I want to really be cautious here, because using the log button, it will automatically put a parenthesis this way, and here's where you got to be careful. If I want to do the log of 10 divided by 2 and I do not close this parenthesis, my calculator will lie to me and give me the wrong answer. So close that parenthesis. Then I could hit divided by the log button, but once I hit the log button, I'm going to get a parenthesis here also. And I've got to close it. And when I do that, I'm going to get this number, 3, whoops, hang on, let me get my pen back. I'm going to get this number, 3.321928095. Let me make sure I wrote that down correctly because that's a lot of stuff. 3.321928095. Okay, if I were to punch that number, whoops, oh my gosh, quit doing that thing. If I were to punch this into my calculator, it would tell me the answer is 10. Remember, what were we shooting for? 2 to some power equals 10. Well, guess what? There is an answer for that. That's the answer. Now, customarily, we round to the 4th decimal place. Because these answers can be extremely large, it is customary to round to the 4th decimal place. So if you check this answer on my worksheet, that's the answer you're going to see. Now, watch out though. If you were going to check your answer, if you were going to plug this guy in instead of this guy, you're not going to get exactly 10. Your calculator is going to know the difference. So if you want to check your answer before you round it off, you got to use the big answer. But let me show you another way to look at this, because I want to make sure we drive home the fact that we practiced a lot of properties and a lot of stuff to get there. See, what I ended up with for my final answer to this question, I ended up with this statement, which I totally could punch in on my calculator. But let me go back to this. I could have gotten there in a little shorter step. I know that if I do the same exact thing to both sides of an equation, I am not changing it. It's a totally valid move. But instead of just doing log of both sides, I could have chosen to do this. I could have used log base 2. Because if I do log base 2 of 2 to the something, that is a property. And I don't have to, rewrite it like I did up here. I don't have to do or show this step. But what's the result? Well, the result is x equals this. But how do I trick my calculator into telling me that answer? Well, I do it like this. That's how I trick my calc into doing it. So there's, two different ways to get to the exact same place. Now, let me show you this one other way to check your answer. Remember, here was my original problem. This equals 10. So my answer that I got was log base 2 of 10. Well, let's rewrite that. What does that look like? 2 to the power of log base 2 of 10. And then once again, without plugging it back into my calculator, this is just a property. What does this thing equal? When this guy and this guy match and you got a value here, bam, there's your answer. It's 10. So I'm trying to show you that we did a lot of laws of logarithms, a lot of property work and everything to get here because we use that information to help us solve problems. Now, let's continue. And let's look at another one that's similar to that. So what if they gave me something like this, 3 to the x equals 20? What if they gave me that? Well, I'm going to do it the shortcut way. I'm going to do log base 3 of 3 to the x equals, well then on this side I would have to do log base 3 of 20 if I'm going to do the exact same thing to both sides. I personally just prefer this way because to me that's just slicker, and I said that's x. But in order to get my calculator to give me the answer here, I would still have to do this. Log of 20 divided by log of 3 so that it would end up giving me the correct decimal. I don't know what that is. I'm punching it into my calculator as I speak. And yeah, this is not a number that I walk around having memorized, but it's 2.72683, yada, keeps going. But we're going to round our answers to the 4th decimal place. So the answer you would see on the practice answer key would be that. All right, let's spice it up a little. Let's just make it a little bit spicier. And you know what? It looks worse, but it doesn't mean it's super brutal. But I do want to make a point here. When they start us off with one of these problems, sometimes you can't tell if it's bases match style or not bases match style until you start messing with it. But this one I tried to make it pretty obvious that when you take away the 6 to get this guy by himself, those bases do not match at all. I could do log of both sides, or what I'm trying to advocate here is the guy who's got the power, pick on him. So I'm going to use base 2, which will cause all this goo to vanish over here, and I get x minus 4. What's it equal? Well, it equals whatever the log base 2 of 5 is. But that's not my final answer. Remember, I'm trying to get x by itself, so I'd add 4 to this answer. Now, the beauty of it is your calculator knows order of operations, so if you punch it in on your calculator correctly and you say, I want to take the log of 5, but I want to trick my calculator into thinking it is base 2, then I add the number 4 to that, it will give you the right answer. But what is crucial is you got to make sure that you are very mindful of closing your parentheses. Because if you forget to do stuff like that, it will lie to you. So, I'm going to punch it in. Log of 5, close the parentheses, divided by log of 2, close the parentheses, plus 4, and my final answer then turned out to be 6.32192. And I'm going to stop right there. I'm not going to write down the rest of the decimal because I can already see I'm supposed to round it to the 4th decimal place, so the answer I'm looking for is 6.3219. Now, once again, if you want to check your answers for any of these, you got to plug it in as the entire numerical value that you had, okay? Or, and I'm just going to show you this once because this is just kind of a mess. Remember, what did the original problem say? The original problem said, 2 to the x minus 4 equals 5, and that was after I got the base by itself. So what was my answer? Remember, this is my answer right here. So if I want to just write it out, it would be 2 to the power of log base 2 of 5 plus 4. That would be this part, minus 4. That would be this part. These would cancel. I would end up with, I would end up with 2 to the power of log base 2 of 5, which is indeed 5. Bam, they match. That's doing it without punching in the long super decimal that we found. Once again, answer key. So you can look and check all your answers. So this next one, here we go. I want you guys to try this one, so I'm going to write it out. All right. So, is it bases match or not bases match style? I don't know, but you're going to have to get the piece with the variable isolated all by itself. So, go for it, pause it, try to do this one on your own, then hit play, see if you did everything correctly. Go ahead. All right. I'm assuming you paused it, you tried it, or you just let the thing play. I don't know. But I'm going to start here and get that 5 out of my way. And I have 4 times 7 to the power of x plus 2. What's it equal? It equals 32. I'm going to divide both sides by 4. And then I have 7 to the power of x plus 2 equals 8. So right there, I say this is not going to have matching bases. So I am going to take log base 7 to both sides because I personally think this method makes it look a little bit slicker. And over here, I'm going to have to punch it in as log 8 divided by log 7. Then I am almost done, but I would still have to move the 2. And as long as I am very mindful of my parentheses, I should be able to punch this into my calculator all in one shot and get it correct. So, one more time, here we go. Log of 8, close the parentheses, divided by log of 7, close the parentheses. Take away 2, or minus 2, not negative 2 on the bottom there, and I end up with my answer, which happens to be a negative number. It's negative 0.93137, etc., etc., but I can see right now that I'm going to have to round this thing off, so my answer turns out to be negative 0.9314. And there we go. That would be the answer you would see on the back, or see on the answer key. I keep saying on the back because I write them as worksheets. Okay, but here's the granddaddy of them all. There's got to be a worst case scenario, and here it is. So, this is the one, and I'm just going to make stuff up, some numbers. Oh, how about 18? I know, this one looks horrible, because now you have to guess a number that would go in on both sides to make this a true statement, and what I'm hoping you notice is the bases do not match. So there's a couple different ways to play this, but I want to play it the easiest way. Here is not the easiest way. Log base 7. Log base 7. Don't do that. You might say, well, on this side of the equation, it makes it much easier because I get rid of the logs. But on this side of the equation, I'm going to have to keep using the trick your calculator change of base formula to keep punching that thing in. It's not the easy way to go. And it doesn't mean, well, what if I use base 18 over here and base 18 over here? Well, then this side's nice and pretty, but this side's going to be a pain in the butt. So here is my word of wisdom. When you have a problem that you know you cannot get the bases to match, and there are variables on both sides, this is the worst case scenario. Do yourself a favor and just use regular old log, common log. What base is this? This is base 10. But why it works, I'm using the exact same base on both sides. But when I have to punch in my final result on the calculator, I don't have to switch bases or trick my calculator or any of that jazz. But I still have to work this one out. So, here we go. See this guy right here? That's a power. I'm going to use the power rule and bring it down. See this guy right here? That's a power. I'm going to use the power rule and bring that guy down. So I will end up with x minus 2 times the log of 7 equals x plus 1 times the log of 18. Now, once again, I'm using base 10, so I can just quickly punch this into my calculator if I wanted to, because that's just a number I don't know. Log of 7 is some weird number I don't know. Log of 18, that's just some weird number I don't know. I could change those into decimals. Now, here's the thing, though. If I convert those to decimals, and let's say I round them off to the 4th decimal place, I will be truncating or shortening the number. I'm chopping off a lot of decimals there. So it will change my answer slightly. Not largely, slightly. So let me show you this. I'm going to do it 2 ways. The first way is I am not going to change these into decimals yet. I am going to assume, though, log of 7 is a number. And if it's a number, I can distribute it. So I would get x times the log of 7. That's just a number times x. Minus 2 times the log of 7. Once again, that's just a number I don't know. What's it equal? Well, let's distribute this number. This would be x times the log of 18 plus, well, 1 times log 18 is just log 18. And here's where you just gotta realize log 7 and log 18 are weird numbers we don't know yet. I want to get x's on one side, numbers on the other. So I'm going to do this and put my x's on the left. So I'm going to take this away. And I'm going to put it over here. And then I'm going to color code this because I think it'll make it a little easier to follow. I'm going to move this guy to the other side. And I end up with, let me go back here, I get x log 7 minus x log 18. What's it equal? Well, it equals the log of 18 plus 2 log 7. Now, this over here, that's a number. I don't know what that number is, but it's just a number. Now, how do I get this? I have 2 x's. This is weird. Well, here's the trick we're going to use. We're going to treat this thing, this x, we're going to treat it like it's a GCF. See, this guy has an x, this guy has an x. So I'm going to factor it out. I'm going to say x times the log of 7 minus the log of 18. What's it equal? It equals this stuff over here. Now, all I got to do now is divide. See, this is a number. I just don't know what it is yet. I'm going to divide log 7 minus log 18. Whoops, come on, pen. And then this is going to cancel. You divide any number by itself, you get 1. 1 what? 1x. I got an x over here. But guess what? If I divide this side by that, I got to divide this side by that. And here's where the fun starts. Keep in mind, I've said this before, calculators have big trouble with division. See, I'm trying to divide one number on the top by one number on the bottom. But you know what? It doesn't look like one number to my calculator until I put this in parentheses. Now it looks like one number divided by one number. However, keep this in mind. When I start punching this into my calculator, so my first move is I'm going to hit the parenthesis key. And I'm going to do this while I write this out. So I'm going to go parenthesis, log of 18. But as soon as I hit the log button, my calculator does this. So I have to close it off. I hope you get my point. It's going to do this again. So I'm going to have to do it here. But that means I have double parentheses on the end. Yes, it does. That's what it means. So when you punch this into your calculator, you just have to be super cautious of all the parentheses that are involved. So I have parenthesis, log, parenthesis, 18, close parenthesis, plus 2 log, parenthesis, 7, close it, close it. I have double parentheses. Now I can say divided by. Now I can say divided by. So I hit my division key, but I have to put parentheses. Remember, don't forget, you got to put parentheses. And then log 7, close that parenthesis, minus log 18, close that parenthesis, close that parenthesis. You have to have everything locked up. And if you do it correctly, you will get the correct answer. And the correct answer on this one turned out to be negative 7.180, wait, 104022. That was the answer that I got. Now, what do? Customarily, we round to the 4th decimal place, and since it's a 0 right there, my final answer would be negative 7.181. You don't have to write the 0 if you don't want to. You're not wrong if you do, but that would be my answer. Now, here's the thing. I don't think this is a horrible, horrible, horrible way to go. In fact, this is the way I do it. I prefer to do it this way. But I could have made a different choice here. Let me explain. I'm going right back to here. I said this at the beginning, and you can still see my little squiggle here. Log of 7 is just a number. Oh my God, my voice is going out. Log of 7 is just a number. If I punch log of 7 in on my calculator, I get 0.84509. Okay, so I'm going to round it off. 0.8451. That would be what I'd get if I rounded it off to the 4th decimal place. What is the log of 18? It's just a number I don't know. If I were to take the log of 18 and convert it to a decimal right now and round it off, I'd get 1.2, what is that? 55, then it says 27 on my calculator, so I'm just going to call that a 3. I'm going to round it to the 4th decimal place. Now, some people prefer to do it this way. What do you mean this way? Well, let me show you. On the one side of the question, we have x minus 2, but now I've already converted it to a decimal, so I'm going to say times 0.8451. What's it equal? Well, what does it equal? It equals x plus 1 times the log of 18. So we have x plus 1 times the log of 18, which was 1.2553. Well, guess what? If I do it this way, I can just distribute this decimal. So on the one side, I get 0.8451 x's minus, well, whatever 2 times 0.8451 is. So 2 times 0.8451. What do I get? I get 1.6902. Okay, what's it equal? Well, on this side, if I distribute, I get 1.2553 x's plus, well, 1 times that number. I'm going to get that number again. And I can get x on one side, number on the other. I'm going to color code this again, or color code this. Oh, come on, please, blue pen. And I'm going to move my x's to one side. And away we go. Oh, come on. I'm going to have to scroll down a little bit. 1.22. Oh, geez. 2553. I really don't want to make a mistake with these decimals, but guess what? That's really the hard part about doing this. So I have 0.8451 take away 1.2553 x's, and I get a grand total here of negative 0.4102 x. That's what I get when I move the x's to one side. Let's move these guys to the other side. Whoop, Okay, so I'm going to add that to the other side, so it's gone. What's it equal? So we have 1.2553 plus 1.6902, which is equivalent to 2.9455. And I want to get x by itself, so let's divide. So I'm just going to divide both sides by this number. X is going to be equal to, well, whatever this divided by that is. And let's see. So I take that number divided by a negative 0.4102. And my answer turns out to be negative 7.18064. And if I was going to round to the fourth decimal place, it would say negative 7.1806. That would be the answer. Now, take a look. What happened when we did it without rounding? See, this answer is based on the fact that I rounded to the fourth decimal place. And this answer right here is based on not rounding. Well, take a look. Here's the thing. We usually work to the fourth decimal place, because if we work to the fourth decimal place, that is usually when we start seeing variation in our numbers. See, if I was to round this one to this decimal place, if I was to round it to there, I would get negative 7.181, which is what I got up here. You see what I mean? So the thing is, I know for a fact that not converting right at the beginning, not converting and doing it this style where I leave everything in terms of log until I definitely, absolutely have to punch it into the calculator, I am definitely more accurate. But I'm only off by a 10,000th, and it's very, very slight, the difference, if I do it decimal style. Here's my belief. Decimal style takes more concentration because you got to be super. And I almost wrote down the wrong digit every once in a while trying to do this problem. Then again, usually when I am doing a math problem, I'm not really talking out loud the same time I'm doing it, just like you guys aren't, but I leave it up to you. If you do work your problem out one way, you might get a slight variation as opposed to doing it the other way. I know this fact exists. I do. So, here is what I'm going to tell you. Let me scroll up to the very top now. This is your practice sheet. Solve each. So these are exponential equations. Some of them you can make the bases match. I mean, I tried to make some of them super duper criminally easy. Like number 4 is super easy. But you don't have to use a logarithm to solve 4. You only have to use logarithms to solve problems where you cannot get the bases to be equivalent to each other. So, I'm going to tell you, the most difficult question on this sheet is 15. The second most difficult question, well, it depends on how you view it, is 8. But 14, here's my warning. See number 14? Go back to my first set of examples. If you do number 14 by taking the log of both sides, you are going to be a very sad kid. It will take you a long time to get that thing, and it might even be wrong when you get to the end. So, don't use logarithms when you can get the bases to match. Number 10 is like that, don't you see? Okay, every single type of problem here I did an example of, but here's your answer key. So what I wanted to point out is you'll see that I have 2 answers, number 8 and number 15, where there are 2 correct answers written down. Why? Well, I did it both ways. Number 8 and number 15, it depends on which method you choose to use. If you do it, I'm scrolling down real quick, if you do it with logarithms this way, you'll get a different answer than you will sometimes when you convert everything into decimal form at the beginning. Okay. Gonna tell you, you know I'm gonna put one like this on the test. I can't not do it. So please practice. And gotta tell you, you don't have to do it both ways. If you choose this method and you get your answer and it matches, congratulations. If you choose this method, personally, I think this method's easier. But you have to be careful with the calculator. But if you choose this method, guess what? You better show me some work on this test. All right? The work better be shown. And if you expect me to give you full credit on this homework assignment, you better show me some work too, because there's a lot. You can't just guess this answer. Nobody's guessing this answer. Okay? Oh, here. That's back to the original. Nobody is going to look, at this problem and say, you know what? I bet you if I plug in negative 7 point, what was it? 1810, blah, blah, blah. I bet you if I plug that in, I'll get it right. Nobody guesses that number. So, please show your work when appropriate and also when it's not appropriate. I understand. I get it. There's not much work to show me for number 4. Okay? All right. So here, once again, pause it. Let me get that mark off the thing. Pause it. Take a picture of it. There's 15 questions. Pause it. Take a picture of it. There's 15 answers. All right, guys. Good luck.